Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have an extract of a question starting from 3.3. It says a constant force F is applied to a 6 kg block to move it up a rough surface inclined at 60 degrees to the horizontal. Force F, which is parallel to the incline, moves the block up the incline at constant velocity. Note that. So we already know at this point that when we see that word constant velocity, it simply means that our acceleration is 0 meters per second square. The block experiences a constant kinetic frictional force of 12.25 newtons. And then we can see our diagram here. Then 3.3.1 says, draw a free body diagram showing all the forces acting on block Q. So for 4 marks, we must show 4 forces. But then we want to just start with our incline there, just to indicate so that we draw everything properly. And then we have our normal force perpendicular to the slope. Then in line with our normal force, we know that it is our FG perpendicular. Then sliding down the incline is always the FG parallel, but then our force is being applied up the slope. So we have our force applied there. But we still have another force that is moving down the incline because it's opposing the motion of the object, which is the kinetic frictional force, right? So we have all the forces there. We've indicated all the forces acting on the 6 kg block, and then that's how they're going to mark them. So 1, 2, and then remember this is 1 mark for the components, then 3, 4, right? Okay. So that's how you were just supposed to indicate those forces there. Then 3.3.2 says, calculate the magnitude of force F. This point, we now understand that if the block is moving up the slope, then this becomes our positive direction up the slope. Then down the slope becomes our negative direction. So we apply our Newton's second law. F net is equals to ma. So note that here we are solving 3.3.2, and then the free body diagram was 3.3.1. Then now we have the force applied minus the FG parallel minus the FK, right? And then MA. So what are we trying to calculate? The force applied, force F, right? So let's just write force applied. And then this, remember, FG parallel breaks down to what? mg sine theta. So let's just substitute in here. Our mass is 6 and our gravitational acceleration 9.8, then sine 60 degrees minus the kinetic frictional force. We are told it's 12.25, so minus 12.25, and then is equals to 6 multiplied by 0 because of constant velocity. Remember, constant velocity means acceleration is 0. So when we punch all this into our calculator, we get negative 63.17 is equals to 0. So we take this, transpose it over to this side. Our force applied is 63.17 newtons. So that's the force F, right? So force F is 63.17 newtons. Then 3.3.3 says the angle of the incline is now increased to 75 degrees. So from 60 degrees, it's now increased to 75 degrees. So that means they're making the slope more steeper now. So the slope becomes more steeper. Then how will this affect the magnitude of the velocity of the block as it moves up the incline? If the force F acting on it remains constant, so your force does not change, still remains 63.17, but then now they've made the slope more steeper. So they say choose increases, decreases, or remains the same. Obviously, this is general knowledge here. We know that the velocity obviously needs to decrease. So the answer here is decreases, because if we are still pushing with the same force here, but then the slope is now steeper, we do understand that the acceleration of the block now will decrease. If the acceleration of the block decreases, it's because the velocity has decreased as well. So that should be the answer there. Then that's how you were supposed to tackle this question, for a total of 10 marks, 4, 4, 8, and 2, 10. So please press that thumbs up button if you've enjoyed the lesson and then you found it helpful. If you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.